Okay, welcome to lesson 6 of topic 27, functions. So if you worked your way through lesson 5 and we're getting the majority of the questions correct, then you can tick off these two, so finding the inverse and also understanding that f to the minus 1 of x means the inverse, so you can tick off those two. The two that we're going to be looking at today are the remaining two. So this one here, which is about kind of combining functions together potentially, or substituting in slightly different terms into a function. And the last one, which is to problem solve using functions as well, okay? So we're going to go with a title of problem solving using functions. So if you copy that into your books, and then we'll have a look at this example. So this is fairly typical in as much as, rather than just ask you a basic functions question where you have to substitute in a number, sometimes they will ask you to substitute in something slightly different, generally an algebraic term. So when you look at this, you've got a function f is defined as f of x is x squared minus 1, okay? And it says find an expression, okay? I didn't type this, so don't start emailing me about mistakes. Find an expression for f of x minus 2. So if you imagine the question was something like f of 6, what you would do is you would substitute 6 in where x is. So you would say 6 squared minus 1, so 36 minus 1, so 35. Now we're going to do something similar, but instead of substituting 6 in, we're going to substitute x minus 2 in. So we're putting x minus 2 in where x is. So that becomes x minus 2 squared minus 1. So that is what f of x minus 2 is equal to. So then we just need to expand and simplify that particular bracket and term at the end. So expanding that properly means I need to use two brackets. And I need to make sure I do my normal expansion for two brackets there. When I simplify that, I'll get x squared minus 4x plus 4. And then subtract 1. So my end answer there is x squared minus 4x plus 3. So that would be your end answer for an expression for that particular function question. Now I'd like you to copy that down and just explain briefly about the fact that it is similar to what you've done before, in as much as when we looked at something like this, you were substituting in 6 where x was. This is just a slight extension and a practice of your algebra as well. So you're substituting in x minus 2 for where x is there, okay? Right, second example looks like this, and the issue with this, I guess, is that it looks more complicated. Okay, when people look at this, a lot of times they won't entirely know how to start the question. But we've got f of x is x squared plus 2x plus 1, okay? Now we need to show that when you do f of x plus 2, take away f of x, you end up with this answer. So this is a show that question, which means we can't just go straight to the answer, we've got to show our steps as how we're getting there, and then that should be the answer once we get there. So f of x plus 2, as we were just talking about in the previous example, I need to replace x here with x plus 2. And I need to make sure in this particular question that I replace both x's with x plus 2, okay? So that's going to look like this. I'll get f of x plus 2 equals x plus 2 squared plus 2 lots of x plus 2 plus 1. So as I said, you just need to make sure you replace both x's here with x plus 2. Now, expanding that, again, you'd use two brackets like in the previous example. You'd expand that and simplify it, and you get x squared plus 4x plus 4. And then two lots of this bracket will give you 2x plus 4, and then plus 1. Now, simplifying all that means I've got x squared here, I've got 6x here, and then I've got 4 and 1 there, so 0 there. Now the question is saying, show that when I work out this, which is what I've got here, so this is f of x plus 2, and I subtract f of x from it, I should end up with that. So let's try that. F of x plus 2 looks like this. I want to subtract f of x, which is this one. And I do that subtraction like I would do normally. So 9 take away 1 is 8, 6x take away 2x there is 4x, and then x squared take away x squared would leave you with nothing. So 4x plus 8. So that has shown that. So we've now done that question because you've shown that when you take f of x plus 2 and you subtract f of x from it, you end up with 4x plus 8 as your answer. So that is your answer there. So again, I'd like you to copy that down. Now the final question is this one. And this is where you start to get into the idea of kind of 4 or 5 marks, somewhere like that. And this relies on our understanding of composite functions, which was a lesson that you did previously. So what you've got here is 2 separate functions. You've got f of x and you've got g of x. And the idea is to try and solve the equation f of g of x equals g of f of x. So this is, again, this is where we're getting more complicated. We're getting kind of grade 8, grade 9, that sort of area. But it's certainly something I think we can do because we understand, hopefully, how to use composite functions. So f of g of x. Now, when we did this, we talked about the idea of substituting the inside one into the outside one. So working from in to out. So we're looking to put g of x into f. So g of x is x minus 9. And I'm looking to put that into where x is for f there. So f of g of x is going to be putting x minus 9 into there. Like that. So now I would want us to expand and simplify that from there. Again, using 2 brackets for a square bracket, you will end up with x squared minus 18x plus 81 plus 4. So simplifying that gets you x squared minus 18x plus 85. So that's f of g of x. What we're looking for now is g of f of x. Now, when we did that lesson, you'll remember that the order is important. We're looking to put the inside one into the outside one. So I'm looking to put this x squared plus 4 into where x is here. So that's going to look like this. X squared plus 4 minus 9. Okay? Now simplifying that gets you x squared minus 5. So I found f of g of x, I found g of f of x. So at this stage in your exam, you're already getting marks at this point. Probably 2 or 3 marks at this stage, probably 3 I would say. You're now looking to solve this equation, and the equation says f of g of x is equal to g of f of x. So this equal to this. So I'll write that now, x squared minus 18x plus 85 equals x squared minus 5. And so I'm looking to solve this equation. So in any equation like that, I want to, when I've got a quadratic, I'm generally looking to get x squareds, everything onto one side, but when I try and do that, if I subtract x squared from both sides here, then what's going to happen is that they will cancel out. And I'm left with negative 18x plus 85 equals negative 5. So now at this point, I'm thinking, well, this is now just a linear equation, so I'm looking to get x's onto one side, numbers onto the other side. So there's a couple of different ways you can go from here. Personally, I'm going to subtract the 85. Which is going to get me negative 5, take away 85 is negative 90. And then I'm probably just going to divide by negative 1 at this stage, so just getting rid of the negative signs. So 18x equals 90. So dividing by negative 1 on both sides gets rid of those negatives, and then I can divide by 18. So 90 divided by 18 is 5. So my answer there is 5. Okay? So I hope that gives you a sense of the sorts of things that you might get towards the latter end of your GCSE in terms of problem solving with functions. I would like you to copy that one down as well. That is, there's been a couple of examples like that in the GCSE fairly recently. So I would like you to make sure you write that one out and just explain what's going on in that question. Once you've done that, have a go at the questions in the booklet, and then make sure you email your teachers if you've got any questions. All right, thank you.